Good morning, students. Welcome back to the another video. Today we will discuss about the topic colloids. So, what are the colloids? Colloids are the heterogeneous system in which one substance is dispersed as very fine particles in another substance. जैसे कि आप सोल्यूशन के बारे में पढ़ते हैं. सोल्यूशन में क्या होता है, एक सोल्यूट जो है वो सॉल्वेंट में डिसॉल्व होता है. सोल्यूट इज यूजुअली प्रेजेंट इन लेस अमाउंट एंड सॉल्वेंट जो होता है वो ज़्यादा अमाउंट में प्रेजेंट होता है. उसी वजह से जो होता है सोल्यूट जो है वो सॉल्वेंट में डिसॉल्व हो जाता है. लेकिन जो सोल्यूशन होता है वो एक होमोजीनियस सिस्टम होता है. एंड व्हेन वी टॉक अबाउट क्लॉइड्स इट इज़ द हेटेरोजीनियस सिस्टम. ठीक है. इसमें क्या होगा, क्लॉइड्स में एक सब्सटेंस जो होगा वो डिस्पर्स होगा दूसरे सब्सटेंस में. जो सब्सटेंस डिस्पर्स होगा वो क्या होगा, डिस्पर्स्ड फेस. और जिसमें जाके वो डिस्पर्स होगा दैट वुड बी द डिस्पर्जन मीडियम. अब आप डिफरेंस देख सकते हैं क्यू सोल्यूशन, क्लॉइड्स और सस्पेंशन में. क्यू सोल्यूशन में जो पार्टिकल्स का साइज होता है दैट इज लेस देन 1 नैनोमीटर, और क्लॉइड्स में जो पार्टिकल का साइज होता है दैट इज बिटवीन 1 नैनोमीटर टू 1000 नैनोमीटर. और सस्पेंशन लार्ज पार्टिकल्स होते हैं जिनका साइज होता है ग्रेटर देन 1000 नैनोमीटर होता है. Hope you got to know the difference between dispersed phase and dispersion medium. On concluding, we can say that dispersed phase is that component which is present in small proportion and is just like solute in a solution. And dispersion medium is generally that component which is present in excess and is just like solvent in a solution. Next is classification of colloids. Colloids are classified on the basis of three types. Means we can classify colloids on three types. Firstly, on their physical state, we can classify the colloids as solid, sol, aerosol, gels, etc. And on the basis of nature of interaction between dispersed phase and dispersion medium. On the basis of nature of interaction between dispersed phase and dispersion medium, we can classify the colloids as lyophilic and lyophobic. And third is based on the types of particles of dispersed phase and dispersion medium. On the basis of size of particle, we can classify the colloids as multimolecular, macromolecular and associated colloids. So, first is based on physical state. When we have dispersed phase and dispersion medium both as a solids, then the type of colloid is solid sol. Examples are gemstones and glasses. In gemstone glasses, the two solids are mixed or dispersed together. Second is solid in liquid, that is solid is the dispersed phase and the dispersion medium is liquid. Now the type of colloid is sol. Means solid in liquid is termed as sol. Examples paint, cell fluids, etc. Third is solid in gas, where dispersed phase is solid and dispersion medium is gas. Solid in gas is termed as aerosol. Examples smoke or dust. Next is liquid in solid. Liquid in solid is termed as gel, that is dispersed phase is liquid and dispersion medium is solid. Example cheese, curd, jellies. Liquid in liquid is termed as emulsion. It is very common. Example milk, hair cream, etc. Liquid in gas, that is dispersed phase is liquid and dispersion medium is gas. It is also termed as aerosol. Example fog, mist, cloud, etc. Gas in solid is termed as solid sol. Example pumice stone, foam, etc. Last is gas in liquid. Example is froth, soap, lather, and it is termed as foam. Now you might be thinking that why there is no mixture of gas in gas. That is why the dispersed phase is gas and dispersion medium is also a gas. Gas in gas mixture is a homogeneous mixture. But here we are talking about colloids, which are the heterogeneous system. So we will not talk about gas in gas. We have only solid in solid and liquid in liquid, while solid in liquid, solid in gas, liquid in solid, liquid in gas, gas in solid, and gas in liquid. Now the second classification is based on the nature of interaction. First case is when dispersed phase loves the dispersion medium, then it will be lyophilic colloid. But if the dispersed phase hates the dispersion medium, it will be termed as lyophobic. So now let's understand the difference between lyophilic and lyophobic. In lyophilic, these salts are prepared by simple mixing of dispersed phase and dispersion medium. As they both love each other and they both are attracted towards each other easily, so by simple mixing they can be prepared. But lyophobic, as we studied, they hate each other. That is, they will move away from each other. So they are prepared by special methods. Lyophilics are reversible while lyophobic are irreversible. Lyophilic colloids are stable due to solvation or hydration, as there are attractive forces present between the dispersed phase and the dispersion medium. But the lyophobic are unstable. Next is viscosity. Viscosity is greater than dispersion medium. In lyophilic, viscosity is greater than dispersion medium, and in lyophobic, viscosity is same as that of dispersion medium. In lyophilic, surface tension is lesser than dispersion medium, and in lyophobic, surface tension is same as that of dispersion medium. Examples are organic compounds like starch, cellulose, gelatin, gum, etc. And in lyophobic, examples are inorganic compounds like metal cyanides, sulfides, etc. Next classification is based on the types of particles of dispersed phase and dispersion medium. On the basis of types of particles, the colloids are classified into three types, that is multimolecular, macromolecular, and associated colloids. Firstly, let's discuss the difference between multimolecular and macromolecular. In multimolecular, when the dispersed phase and dispersion medium are dissolved, atoms or smaller molecules will aggregate together to form a species having size in the colloidal range. यानी कि मल्टी मॉलिक्यूलर में क्या होगा, जब डिस्पर्स्ड फेस और डिस्पर्शन मीडियम को दोनों को डिसॉल्व किया जाएगा तो उनमें जो एटम्स या स्मॉलर मॉलिक्यूल्स प्रेजेंट होंगे वो इकट्ठे हो जाएंगे और एक ऐसे पार्टिकल्स बना लेंगे जिनका साइज जो होगा वो colloidal रेंज के बीच में होगा. And in case of macromoleculars are like the proteins or the polymers which aggregate together to form a species having size in colloidal range. ये भी combine करेंगे, लेकिन ये जो है ये proteins या polymers से बने होते हैं. Macromoleculars are basically the proteins or the polymers which will aggregate together to form the species. Example of multimolecular is gold, sulfur. Macromolecular is starch, cellulose, proteins, enzymes, and polymers. Next is associated colloids. Associated colloids are those substances which at lower concentration behave as normal strong electrolyte but exhibit colloidal behavior at higher concentration. यानी कि एसोसिएटेड क्लोइड्स एक ऐसे तरह के सब्सटेंसेस होते हैं जो कि जब उनकी कंसंट्रेशन कम होगी तो वो नॉर्मल स्ट्रॉन्ग इलेक्ट्रोलाइट की तरह बिहेव करेंगे, लेकिन अगर उनकी कंसंट्रेशन इंक्रीज हो जाती है तो वो क्लोइडल बिहेवियर दिखाना शुरू कर देंगे. ये जो एसोसिएटेड क्लोइड्स होंगे जब एग्रीगेट करेंगे देन दे विल रिजल्ट इनटू द फॉर्मेशन ऑफ मिसल्स. These micelles are formed at a particular temperature and concentration. So the concentration at which or above which the micelles are formed, that is known as critical micelles concentration. That concentration is usually 10⁻⁻⁴ to 10⁻³ molar. Next is craft temperature. It is a temperature above which the missiles are formed. Remember the term above. It is not at. At और above में difference होता है. At तब होता है जब उस temperature पे बनना शुरू हो जाए. Above means उस temperature से ऊपर. तो यहाँ पे जो concentration है that is also above and the temperature is also above. As we studied that the associated colloids aggregate together to form the micelles. So let's discuss the mechanism of formation of micelles. The cleansing action of the soap is only because of the formation of micelles. The soap consists a salt of fatty acid. This soap is generally a sodium salt of higher fatty acid, that is RCOONE. Taking an example, sodium stearate, which is C17H35COONE. The sodium stearate decomposes and forms C17H35COO negative and Na positive. So, soap has two parts, that is a long hydrocarbon tail and a hydrophilic head. This C17H35 acts as a long hydrocarbon tail and this COO negative part act as hydrophilic head. Whenever soap is dissolved into the water, then the arrangement of the two parts in order to yield the formation of micelle is in such a way that RCOO negative ions are present on the surface with their COO negative groups in the water and the hydrocarbon chain are staying away from it and remain on the surface. The most common application of soap is the cleansing action of soap. The soap molecules form the micelles in the oil droplets in such a way that hydrophobic part is present in the droplet and the hydrophilic part is away from the oil droplet. For example, we have a cloth on which the dust particles or the oil droplets are present. The soap part will approach these dust particles and they will arrange themselves in such a way that the hydrophobic part is present in the droplet. This hydrophobic part is the long hydrocarbon tail and the hydrophilic part, which is the COO negative part, will remain away from the oil droplet. In this case, this is the oil droplet, then the hydrophilic part is away from the oil droplet. And when the water is supplied, this whole dust particles will get removed and we get a cleaned cloth. In this way, the soap acts as a cleansing action. The next topic we will cover in the another video. The link of the next video will be available in the description box. To watch more videos, please like, share and subscribe my channel. Thank you.